What is up, everyone? Welcome to an episode of Moralis Blueprints, in which we show you how to start your Web3 development journey by building cool Web3 projects with even cooler Web3 tech. In this video, we're going to build a decentralized exchange using the Moralis Web3 API for token prices, the 1-inch Aggregator API to actually make the swaps, the Wagmi Web3 library to connect your wallet to a React app. We're going to build a React app for the front end, and for the back end, a NodeJS Express app. But before we get into the tutorial, let's look at this final product to see what you're going to learn how to build. So we have this very cool interface where you can swap the tokens that you want to change. Tether USD to, for example, Uniswap. Let's change this back to USDC. You can swap them around like so. We're automatically getting the token prices. So as you enter a price, you'll get that swapped over here in the second input field. How sweet is that? Then you can connect your wallet over here. Let's connect my account 1, where we have, I believe, some USDC. Let's check out our wallet. We have 5 USDC tokens, but we don't have any Uniswap tokens. Let's import Uniswap into my wallet. Uniswap over here. Next, import tokens. And check out, as we make this swap, we should get some Uniswap tokens. So let's change 4 USDC tokens for 0.63 Uniswap tokens. Let's swap. 1-inch Aggregator API gives us a quote where our tokens for USDC will be changed to 0.63 USDC. We'll have to pay $3 in gas in Ethereum. We confirm this transaction and we get this nice process of the transaction is pending. We can also follow this on MetaMask over in here. Our 1-inch aggregator found the Uniswap decentralized exchange to have the best rates for the swap. So we wait for that pending to go through. That's gone through, and now that should be reflected over here as well. The transaction is pending state, should say change to transaction successful. And now checking out our MetaMask wallet and our assets, we only have 1 USDC coin left, but we have 0.6 Uniswap tokens valued at 3.97 United States dollars. How cool is that? We also have a functionality to advanced settings for setting the slippage tolerance from 0.5%, 2.5% to 5.0% to make sure that your transactions actually go through. But if you're excited for this build, stay stuck in and we'll show you how to build this from scratch today. Stay stuck in and let's get started.
Hey, I'm Jay, your Moralis instructor from beautiful Finland.
I got into crypto in 2020 and I've been building in the space ever since.
In my free time, I enjoy running and at the gym, and in the summer, you'll definitely find me at the golf course. Now, let's get stuck in and learn about Web3.
Rightio, let's get started with this project. So open up your favorite development environment. I have Visual Studio Code open and a folder in which you want to create this project. And to get us off to a flying start, I prepared a starter repo that's available in the link in the description. It'll take you to this GitHub page. And what you can do is just press this code button over here and copy the link to this repo. And then we'll go ahead in our development environment and clone this repo into our folder. Git clone and this address over here, and this will start cloning your DEX starter repo over into your folder. And once that's in here, let's go ahead and move into that folder. CD DEX starter in your terminal like so, and let's go ahead and open this, and you'll notice that we have a front end which is called the DEX, which is a simple React file, and then we have a back end which has a simple NodeJS file over in here. But as you'll notice, we haven't configured any of this yet, and that is the idea of this tutorial. You'll learn step by step how to make calls to different Web3 endpoints to get the prices of tokens, make swaps of tokens, and in the front end portion of the build, if we jump into the DEX folder over here, you'll notice that we have a app.js, which is totally empty, and the index.js just shows us we have a React app ready to get going as we start off with this build. So first things first, let's go ahead and install all the dependencies for this project. Let's go ahead and clear the terminal for now. And then let's go ahead and start off with the front end. So CD into the DEX folder and go ahead and run npm install. So this will install all the front-end dependencies we have for this project, and then we can go ahead and jumpstart the project and see what it looks like in its starter form. All right, now that everything installed, let's go ahead and run npm run start, and this should open up localhost 3000 for you. Like so, and we have this nice gradient background and we have a DEX title over here. And this is the basis for our project, and we'll start off by building all the features for the front end of this page, and then we'll slowly delve into creating a back end with Moralis to fetch token prices and also integrate with the 1-inch Aggregator API to actually make swaps of ERC20 tokens. At the end, you'll have your fully fledged decentralized exchange. So now let's jump back into Visual Studio Code. And here, what we can do is close down the terminal so we have a bit more space, close down the index.js file, and jump into the app.js file. So this is going to be the main root of our front-end project. And what we're going to do is build it out with these components over here. We have a header, which will have the header of every page. Then we have a swap page and a token page. And the token page is something that is an extra challenge for you at the end if you want to build out this further and kind of have a list of tokens, but we'll focus on the header and swap components for this build. Now, jumping back into the app.js file, let's go ahead and use this header component. So let's go ahead and import it. Import header from the components folder and the header file over here. And then we can go ahead and use it here in our app component. Let's go ahead and place our return statement in brackets over here. Copy this. Command X and paste it in here. And rather than just pasting DEX, let's add our header component in our app div. And throughout this build, you'll notice that we've given class names to our different tags. And this is because I've already prepared a app.css file with all the CSS styling for this build. So if you're interested in the CSS styling of how to make things look pretty, you can always go ahead and check it in here, but we'll be referring to them in the class name tags to speed up the process of this build because we're not focused on styling, but the actual Web3 functionality. So now let's go ahead and use our header tag, which we've created a component for, and add it to our app component. Let's get rid of this semicolon over here. So now everything should be working nicely. Let's go ahead and save. We can actually go into split screen mode so we can see the changes we're making live on our browser. Like so. So now we're in split screen mode. We have Visual Studio Code open and our localhost 3000 on our Google Chrome web browser running over here. And you notice that the DEX heading has changed to a header because now we're not rendering the text DEX over here, but we're using from the components, the header component over here, which has a div named header. By changing this, this is what will change into our browser like so. Let's go ahead and redo that. So now we have the header, and now let's start off by making a nice header. We'll have our logo in the top left corner, a couple of page options, and then a connect button over here on the right. So let's go ahead and move into building that. Let's close out the file structure over here so we have more space in our header component and start by importing all the things we need for this header component. All right, so what we'll have is two images. We have a Moralis logo, which is stored in the file directory, and a ETH logo. The ETH logo will represent the chain the user should use to access the swap. So we'll configure this for Ethereum, but of course you could figure it for other chains as well, like Avalanche, Polygon, whatever you'd like your decentralized exchange to be on. But now, moving on into the header component, rather than returning just a div with a header text, let's go ahead and actually make a header tag. Header like so. And in this header tag, we'll create a div with a class name equal to left capital H, which will have all the components of our header we want to be on the left side. So the logo and the different pages. So let me just go ahead and paste these over here like so. So we'll have an image, which has our logo we imported at the start over here. We have our first header item, which is the swap page, and the second header item, which is our tokens page. So if we go ahead and save this, what you'll notice is that now we have a nice header over here. We have our logo in the top left. We have two page options. And in a moment here, we'll actually link these with the React router so you can actually go to these specific pages. But for that, we'll have to set up the routes in our app.js. Now let's go ahead and work on the chain selection and the connect button we'll have in the top right corner of the header. For this, we'll create another div and we'll give it a class name of equal to right H. Close that div. And in here, let's go ahead and paste the items we want in the top right corner of our header, like so. So now we have another header item, which is like the swap and token header items we have over here on the left side. But this one will have an image of our logo, the chain of this decentralized exchange, which is Ethereum. Here you could place your other options, but then we also have a connect button, and the on-click connect event we'll do later, so we can remove that. And then we have a connect button that pops up over in the top right corner. And now our header is looking awesome. Now, as it is in split screen mode, it is a bit crowned, but as you go in full screen mode, everything looks absolutely beautiful. So now we have a lovely header, and that didn't take any time at all. And now, as I said, now everything is just on this localhost 3000 page, but we want to have different routes for the swap page and the token page. So let's go ahead and jump back into the app.js page and create the routes for these two pages. Our React app is already set up with React Router in the index.js file. So what you can do is go ahead and import from React Router routes and route from React Router DOM. And because we want to route to the swap and token components we have in our file structure over here, we have to import those as well. Let's import them under our header over here. And then after that, you can place a main window div below your header. So create a div, give it a class name of equal to main window, close up that div, and in here we'll place our routes like so. So we have a routes tag, and within that routes tag we have two routes, one which will be the main page, which is the swap component, and then we'll have the tokens component taking us to the tokens page. And as we save that, we should get a swap text pop up on the page, as now we're on the main page, which is the root route, and the swap component should have a text called swap. Let's save this. And look at that, now we have swap. And as we move to the tokens route, tokens, now you get the tokens tag over here. And as I said, we'll be focusing on the root route for the swap page and build out the swap functionality, but the tokens page is something you could build out further later on. But now we also want this routing to work from our selections over here in our header. So jumping back into the header component, we have to bring in link from React Router like so, and then wrap our header items over here within link tags. So let me just paste them in over here. Voila. And now our two header items are both wrapped around their own link component with a class name of link. The swap page will take us to the home route, and the tokens button will take us to the tokens route. If we save this, now we go ahead and press the tokens component, that takes us to the tokens page, and pressing on the swap button, that will take us back to the swap page. So now, without focusing on the functionality of our connect button, we have a fully functional header, which takes us to the different pages of our decentralized exchange. How sweet is that? And we can move on to working on the swap component over here, which will have our nice modal with all the different options of changing our tokens, our ERC20 tokens to other ERC20 tokens. Let's move on to that next. Rightio. So now with our header component ready for now, let's go ahead and close that and jump back in to our components folder, and we have the swap.js file, and we'll start working on this. Let's close down the file structure so we have more space. And for this project, we're using a UI framework called Ant-Design. So to help us out, let's start off by importing all the components and icons we'll be using from Ant-Design throughout this swap component build. So pasting them over in here, we'll notice we have different things from Ant-Design. The components we'll be using are the input, popover, radio, modal, and message. And then different icons will have a arrow down outlined, just a down outlined icon, and a settings outlined icon. But you don't have to worry about these too much. I'm just importing them here at the start so that we can easily access them when we need them for our different UI features. So starting off in our swap component, let's go ahead and give our main div, we'll be using a class name which will be equal to trade box. Go ahead and save that, and you'll notice a nice box for our swapping pairs to be populated in. Now, of course, we have the swap header, which we can remove from over here, and go ahead and make a div for our trade box's header. So go ahead and create a new div, give it a class name of equal to trade box header, close it up, and in here we can make a number for heading, which we can say swap in. Let's see what this looks like. Save that, and now everything looks a bit neater. Now on the right side, we can apply some settings. So for example, when using a decentralized exchange, you'll have slippage tolerances. So although you're presented with some sort of initial price that 1-inch aggregator fetches you, these prices might change. So to avoid your transaction or swap of tokens going through with a different price you've selected, you can set a slippage tolerance. So let's go ahead and create a settings button over here. First of all, let's go ahead and use the settings outlined icon. And for the class name, we'll give it a class name of cog, like so. Save that, see what happens. Now we have a nice settings button over in here. It even has a nice animation which turns around 90 degrees when you hover over it. But now we'll also want a popover functionality. So as you click it, you'll get the option for setting your slippage tolerance. So let's create that. Let's wrap our button in around a popover element from Ant-Design, like so. So here you see why we're already bringing all the different components at the start. Let's go ahead and indent this, close our popover, like so, and then provide some functionality for our popover. First of all, we'll give it a title, which will be equal to settings, of course. What will trigger this popover trigger will be equal to a click. And of course, you can find all this information in the ant-design documentation. And then the placement of our popover, we'll want it on the bottom right. So let's go ahead and place bottom right as the option over here. Let's go ahead and save that. And now as you go ahead and click our icon, what you'll get is a settings popover. Now for the content of this popover, we'll want to have those radio buttons to select which slippage tolerance we want for our trade. So let's go ahead and create a content over here. Content, which will be equal to a settings component that we have to create. So creating that settings component over in here, what we'll do is create a variable called const settings, which will be equal to a UI component. Let's go ahead and give it some tags to fit it in. And let me just paste it over in here like so we can talk about it. So we have a heading called slippage tolerance. You could also provide other settings as well if you'd like to. We'll just have the slippage. And then we have a div in which we use ant-design radio group component, giving 3 options for radio buttons. We have a value of 0.5 for the slippage, which will reflect a 0.5% slippage tolerance, and the same for 2.5% and 5%. And of course, for the radio buttons, the value will be a slippage variable, and on change, we have a function to handle slippage change. So we have to create those, and for that, we'll have to bring in from React use state. So over here in the top, bring use state from React, and we might as well bring use effect as well at the same time, as we'll be using that later on in this build. So at the start of your swap component, we can create a state variable called slippage like so, and then we set the slippage over in this set slippage hook. So go ahead and use state, and we'll start off with, for example, 2.5 as the initial state. And then of course we have to create that function that we called handle slippage change over here. So go ahead and create that function handle slippage change. And this function, all it will do is use the set slippage to set our slippage state variable to the target value selected in the radio buttons. So that should have us set. Let's go ahead and save this now. And we get 2 errors. E is not defined and settings is not defined. So what we used over in our popover was settings, not settings. So let's go ahead and change this variable to settings. And then for our function over here, we have to pass the argument that the user selects. So E, let's go ahead and save that. And now all the errors have gone and we should be able to use this. Look at this. Now we have a slippage tolerance and we have this nice radio button interface where we can set the slippage tolerance we want for our swaps. How sweet is that? We're making great progress. And now let's go ahead and move on to the actual input fields for our tokens. So scrolling down to our return statement where we're rendering everything, let's go ahead and in our trade box, underneath our trade box header, let's go ahead and create a div with a class name of inputs like so. Then what we'll do is create 2 input fields over in here from ant-design. So we're bringing in input. So what we can do is bring those in like so. Let's open this up in full screen for a moment so you see what we brought in. So we have 2 inputs as a placeholder. We'll have them both set to a 0 value. So in here, you'll place the amount of tokens you want to swap. And as you see, the value is set to token 1 amount and token 2 amount. And for the first one, we have a onChange function, which will change the amount to whatever the user inputs. And the second one is disabled, as here we will be using the Moralis token API to fetch the token price for both of these tokens, and it'll automatically render the amount of tokens this token 1 amount will be swapped to if you swap them to token 2. And over here, I'd also want to mention that these input components you'll see as we go ahead and render this page will not be the standard ones from ant-design. What we've done in our index.js file, our index.css file, we've given some custom code for our ant-design components. Our ant input over here, we've given some custom code to make them look nice. So again, you can check out the CSS styling for all the custom code we've given for ant-design components over in the index.css file. So now in the swap.js file, what we have to do is set our state variables for token 1 and token 2, and then create this onChange function for changing the amount. So over here in the top, let's go ahead and paste the 2 state variables in here like so. So we have token 1 amount And both of them are highlighted now because we're already using them, and we have the setting of these variables as well. And we set both to null at the initial state, so we'll use the placeholder of 0. Now, what we'll also want to do is add that function, and it'll be very similar to the setting of the slippage. We're just changing the amount of token 1. So over in here, let me just paste it in. The function change amount, and we take the user input and the target value we change to the token 1 amount. Later on, when we fetch the token prices, we'll also set the token 2 amount based on the token prices given from the Moralis token API. So let's go ahead and go back into split screen mode. Let's close down this so we see it a bit better and save, see what happens. And now we have 2 nice input fields over here. Look at this, so quick progress, and we can change our token 1 amount, but token 2 is disabled and you can't change this because that will be dependent on what you set for token 1. So now following this, what we can do is add an indication of which token both of these inputs represent. So let's add a token field over here on the right side for these input fields. So scroll down over to your inputs over here, and underneath them, we'll go ahead and create a div with a class name of equal to asset1 as shown over here. And in the CSS for asset1, it is positioned relative to this inputs div and will be placed nicely over here in the input field of input 1. So let's go ahead and save this, see what it looks like. And now we have a nice little place where we can add the logo and the ticker value for asset 1. And we can do the exact same thing, but this time for asset 2. And again, the styling is in the app.css file, so you can check that out from there. And that will create a nice field for our asset 2. But to be able to decide which assets to show in here, we'll have to have the image variables and the tickers. And for that, I've also sorted you out. So for that, let's go ahead and open our development environment in full screen for a while. Let's go to the top over here and open up our file structure. So in the source folder, if you travel to the bottom of the source folder, you'll find we have a tokenlist.json file. And in here, we have an array with all these different tokens. And for all these tokens, we have the ticker value, an image associated with this token, the name of the token. For example, for USDC, it'll be USD coin, and the actual on-chain address, which represents this token on the Ethereum network, and the decimals, which will help us out when actually making the swaps. So we have USDC, we have Link, USDT for Tether, we have Gemini USD, we have wrapped Ethereum, wrapped Bitcoin, Matic, Uniswap, all these tokens. But if you want to add some more, you can do so. And you can, if you're using a different chain, of course, use the addresses on those chains. But this is kind of a file to help you out with all the different coins you want to be swappable on your decentralized exchange. So what we'll do is import this tokenlist.json file into our swap.js file. Let's keep this open for now. So in our swap.js file, over at the top, let's go ahead and import this token list. Import token list from our tokenlist.json. And now what we can do is use, for example, at the start of every render, we use USDC and Link, the first 2 items in our array, as the options for token 1 and token 2. So we can use the image variable and the ticker variable of each of these objects to present them nicely in our divs over here. So let's do that straight away. For asset 1, we can do this. Let's close down our file structure like so. So what we do is add an image tag with the source being token 1 image and the class name asset logo. And then we paste the text for token 1 ticker. So we use the image and the ticker. And then we also have a down outlined icon to kind of represent a opening of a modal of selection of changing your tokens. But you'll notice that we have a token 1 variable that we do not have set in the swap component. So we'll have to create that state variable that we can then change in the future and initially set it to the first item of our token list.json. So jumping over to the top, let's go ahead and add that here, and we might as well add token 2 like so. So now we have token 1 and token 2, and they're set to our token list first element and second element, so USDC and Chainlink. And now let's paste the same thing over here. We have our asset 1 and do the same thing for asset 2. We can just copy this over from here, paste it in here. And rather than having token 1, let's go ahead and do token 2 like so, token 2. And now as we go ahead and go to split screen mode once more, go ahead and save this. now you'll see all these render automatically. We have a nice USDC coin over here with the logo and chain link over here. And if we go ahead and change these, for example, to token list 5, let's see what happens then. We get wrapped Ethereum. Let's change the first one to token list 7. Let's see what we get. We get Matic and automatically the logo. So this is how sweet our DEX is already. It's looking very, very clean. Now let's add a functionality to swap these two tokens around. So add a button over in here between, because sometimes you might be on the wrong token. You want to actually do the swap between WETH to Matic. So let's add a functionality to make that easy and the user experience as smooth as possible. So I kind of like USDC and Link. So let's change these back to 0 and 1 like so. Save that. And now scrolling down, what we'll have is under our input, we'll create another div, and let me just paste it directly in here. Go ahead and jump into full screen mode for a moment so you see what's going on. We have a div called class name switch button. And within that div, let's go ahead and indent this nicely. We have a icon from Antisign Icons, arrow down outlined, which will kind of indicate that you can swap this token into this token, kind of flipping them around. And to trigger this functionality, we have an on-click event, which fires the switch tokens function. So let's go ahead and create that function underneath our functions over here at the top. Function switch tokens. It doesn't take any arguments. And all it does, token 1 state variable in this variable called 1 and the token 2 variable in this variable called 2. And then let's go ahead and set the token 1 and token 2 to these 1 and 2 respectively. So essentially swapping them around like so. So we use the state variable useStateHook to set token 1 to token 2, and we set token 2 to token 1, effectively swapping them around, creating a nice user experience. Let's go to split screen mode, save this, and now look at that. We get a nice button over here in between, and as you press that, you swap between Link and USDC, and it works for any pair as well. Let's go to, and for example, 9 over here, save that. We have Tether and Curve DAO. Let's go ahead and swap those around, and that is beautiful. Next step, of course, is creating a modal. So when you press these buttons, it gives you a nice modal where you can select between any of the tokens in the token list.json file. Let's change these back to USDC and Link like so, save that, and now we have this nice swap button. Works awesome. So now focusing on that modal, we have brought in from Antisign as well, so we can go ahead and just create that modal. Over here at the top, we created actually above our trade box div because it will be on top of all that we render on this swap component. So over here, we can do a modal like so. Then everything went red, so we have to provide these tags around the whole return statement over here. Like so. React likes that way better. And then for our modal, let's provide some arguments. So over here, let's go ahead and provide our arguments like so. So our modal will be open if the isOpenState variable is set to true. We won't have a footer on cancel. So on close of this modal, we actually set the state variable isOpen to false, and then the title of the modal will be select a token. So let's go ahead and create that isOpenState variable over here at the top. Let's go ahead and add a state variable in here. Like so, isOpen and set isOpen, useStateHook is set automatically to false. Let's go ahead and save that. And now let's create on click for our asset 1 and asset 2. The isOpen state variable will be changed to true. So let's create that on click event over here. Like so, opening this up full screen so you see what's going on. On click, we call a function called openModal, and we pass it an argument of 1. So because we have to know which token we want to change, we have to pass an argument to we have to call a function called openModal, which will set our isOpenModal to true. We do the same thing for asset 2. On click, we open modal, but this time we pass an argument of 2. And now let's go ahead and create this open modal function and actually create another state variable before that, which will store the asset number, asset 1 or asset 2 we are currently changing. So change token and set change token, we initially set it to 1, but our open modal function will change this to whichever button we press. So go ahead and create another function underneath our lowest function over here. Function open modal. It takes one argument, which is the asset. And then all this does is it changes the asset being changed. like so, set change token to asset, and set the modal to be open to be true. So everything should be working nicely. Now, as we click asset 2 or asset 1, we should open a modal, and in the background, we set the state of which token we are changing. Let's save this. And now, as we hover, we can press and we get to select a token. We can close this, and the same thing for this. So both of these buttons are working. Of course, the styling isn't there yet because we haven't provided any contents for our modal, but we'll do that next. So close this and jump into our modal over here, and let's start filling this out. So going ahead in our modal, let's create a div. First of all, give it a class name of equal to modal content, just like so. And then in our modal content, what we'll do is we'll take our token list and map through it. So we'll get an option of choosing between all of these tokens in our token list. So go ahead and get the token list. Let's make sure that React has got it. So we add a question mark and then we map through it. We'll take each element and the index of each element. And then within that, what we'll do is we'll return information about each element. So let's go ahead and return. And this I'll just paste in for simplicity's sake. And then we can go ahead and talk through this. So let's open this up full screen for a while. What we have here is we have a token choice div in which we then have the image of each token. So because we're looking at each object in the token list, we can get the image of each token. And then we have the token choice names. So we have the token name and the ticker displayed as well. And all the styling is made nice. Of course, on click of any of these token choices we have in the token list, we'll modify the token, but we'll create that function a bit later so we can go ahead and comment that out for the time being to see this in action as we open the modal. So let's go ahead and save this. And now, as we click USDC over here, look at that. We have a list of all the tokens with nicely presented token icons, names, and tickers. And all of them are over in here. We have Shiba Inu, Aave, Uniswap, Rat Ethereum, all this looking beautiful. And then Chainlink as well. All this is the same as we can swap between these tokens. But now we have to create this modified token function. So as you click Tether USD, it goes ahead and closes the modal and changes this token to Tether USD or whichever token you click. So let's go ahead and uncomment this that we just commented and go ahead and create this modified token function, which takes as an argument the index of our token list we want to change our token to. So let's go ahead and jump over here in our functions. Let's go ahead and create a function called modify token. It takes an argument of I, and then go ahead and create a simple if statement which checks our change token variable to see which token we are changing, and then based on that changes the token on our token list to the ith element of our token list. So if change token is equal to 1, we'll change token 1 to token list element I, and the same thing if it's change token 2, we set our token 2 to the ith element of token list. So everything should be working phenomenally right now. Go ahead, and also what we have to do is set the modal to be closed. So set is open to be false. So that just nicely closes our modal after we swap the tokens. So now going ahead over here, USDC, we could change to DAI stablecoin. Look at that, works phenomenally well. For Chainlink, we could do wrap Bitcoin, and look at that, how sweet is that? And then we can swap them around like so. We are absolutely flying through this USDC back to Chainlink. How cool is that? Everything is working phenomenally. We can even change the value like so. Now I believe the last UI features are creating that swap button, and then we can go ahead and move on to creating that backend where we call the Moralis token API to fetch the token prices for these two tokens and actually render the correct amount of tokens. Any amount we set in this first input field would change to in this second token. So let's go ahead and create that swap button now. Jumping back into our swap component at the bottom of the page. Here beneath our inputs div over here, what we can do is go ahead and let's just open this up full screen for a while. Let's add a div called swap button, and on click, we will have a fetch decentralized exchange swap, but that'll be later on in the video when we're actually making the swaps and using our 1-inch aggregator API to make the swap. Now we'll just have it disabled if we don't have a token 1 amount. And then what I'll say is swap, simple as that. Let's go ahead and save this. And look at that. Now we have a swap button, which is disabled now because we don't have a token one amount. But as soon as we add an amount, the swap button activates and we could essentially click it if we had a on-click trigger over here in the div. But that is essentially the front end pretty much completed. How sweet is that? We've done a whole lot in a short period of time. We have the settings over here, which we can swap the slippage tolerance. We can change between pages. And like I said, the tokens page is something you could build out further to see all the tokens. You already have the tokenless JSON file. We just focused on the swap functionality over here. You can change the tokens, Gemini USD. You can go to Uniswap tokens. You can swap them around. How sweet is this? You can go to USD coin, back to Chainlink. And as you add some value over here, you can swap. And I think this is a great moment to start working on our back end where we call the Moralis API to actually fetch the token prices for these two tokens, as we already know their on-chain addresses, and we can use those with the Moralis API to get the prices of each of these tokens in US dollars, get the ratio, and that way calculate the amount of 41 USDC would convert to in Chainlink tokens. Later on, we'll also connect with Wagmi, so we can actually connect our wallet to the page, and then we can make our swaps using the 1-inch aggregator. So now jumping back into Visual Studio Code, what we'll do is go ahead and close out our app.js file and our token list. We'll leave the swap just because we'll get back to this as we're making the calls to our backend. But what we'll do is to open up our file explorer. We can go ahead and close the front end file and open up the dex.back. And here you'll see you have a env.example file. Let's start over with this. So the env.example file will have a Moralis key, and you can get yours from moralis.io. So let's go ahead and start off with that. Let's jump into moralis.io, open up Google Chrome, and arrive at the moralis.io web page. You can go ahead and start for free. It's totally free, or then you can log in. So I already have an account, so I'll log in, and this will take me to my admin dashboard. So this is what the admin dashboard looks like. There's a lot of resources like the API reference and tutorials we've made to get you started with Moralis. We also have a video to get you started to navigating around the Moralis admin dashboard. But all you need is jump into the Web3 APIs. You can get your Web3 API key over here. It's very important to keep this safe as you don't want anyone else to get access to your Moralis account. So just copy it and jump back into Visual Studio Code and paste it over here into your Moralis key in these parentheses. I'll paste it and then I'll jump here into the index.js file. Like so, my API key is now in the .env, and what you'll have to do is also go ahead and rename your env file to just env, no example. So like so, we are ready to start working on our backend, which is a NodeJS Express app. Everything's set up for you. What we want to do is go ahead and open up our terminal. We currently have our front end running over here. So let's create a new terminal. And over in here, let's cd into the DEX starter folder, DEX starter, and then cd into the DEX back, which has the back end of your project. And what we can do here, as well as we did with the front end, install all the dependencies for our backend, which is npm install. And that should get you going with all these dependencies, Express, Moralis, cores, .env, and so on and so forth. Beautiful. And if this is your first time working with Node.js Express, we can give this a go and see how it works. So let's close this terminal down for now. We're running on port 3001. So as we start off this backend server, we have one endpoint called token price. It's returning a USD price variable that we haven't created yet. So it's very important to remove that and just, for example, respond with an object, an empty object. Let's go ahead and save that. And now you are actually ready. As you run the starter script, which is node index.js, we'll start Moralis with your Moralis key and then start your server on the port we defined over here, which is 3001, as our front end is running on port 3000. So what you can go do in your terminal for your backend is go ahead and run node index.js. And this will start your backend server. You should get a prompt saying listening for API calls. And we can actually open up our browser and make a call to localhost 3001 to the token price endpoint. And as a response, we should get an empty object. So open up your browser and over in here, type in localhost 3001 token prices. Like so. So localhost 3001 token prices should give us a response of an empty object. Or I might have misspoken there. I said token prices, but actually the endpoint was token price. As we search for this, as a response, we should get an empty object. And look at that, we get our empty object as a response. How sweet is that? So now let's go ahead and start working on making a Moralis call over here. And it is very simple. You can always check out the Moralis documentation. Let me just show you. docs.moralis.io will get you to the Moralis documentation where you have the references. You can get all the Web3 data APIs over in here. We have, as you scroll down, the token API where we'll be using the get ERC20 token price endpoint. And there's clear instructions on how to use it over in here. You have different languages we can use. We're of course using NodeJS ourselves right now. But this is where you can find all different endpoints if you want to try something else out. But for now, we'll just be using the get ERC20 token prices endpoint, and let's start it over in here. And I think you won't believe how simple this is. So starting off, when we make a request to our token price endpoint, we can provide request query parameters, and we can fetch those query parameters by destructuring them from the request we've sent over. And then we can go ahead and already make our Moralis EVM API call. So we'll do one call first for our token 1. Response 1 is what we'll call it. Response 1 will be equal to awaiting Moralis, and the EVM API, you'd notice it's completely typed, so you have all the different functions you can use. We'll use the token method, and we'll use the get token price endpoint like so. And all you have to pass for this endpoint is the address you want to get the token price for. You'd also have to provide the chain, but as we're on the Ethereum chain, that is the default chain, so we don't have to pass that as a parameter. And then from our query we send to this endpoint, we can get the address one we send. So we have to make sure that when we make a request to token price, we provide a address one query parameter, which will have the token address of our token 1. Then we can do the exact same thing, but this time we'll do a response 2, where we make another request to the Moralis token price endpoint, but we get it for our address 2. So now we should have the response for the prices of 2 different tokens. And what we can do, for example, here, we can do a console.log of response1.raw, the raw format of the response, and we can do a console.log of response 2 as well. Like so, console log response 2 over here. And now we have to go ahead and restart our server because we haven't installed Nodemon. Let's go ahead and run Ctrl+C in our terminal and go ahead and run node index.js. And we're again listening to API calls. So now as we make a request to our port 3001 token price endpoint, passing 2 query parameters for address 1 and address 2, our terminal should show the response of the price of these 2 assets. So let's go test this out. Jumping back into Google Chrome. Again, let's go ahead and make a request over here to localhost 3001 token price endpoint, like so. But now adding a question mark, we can add the token parameters here in our browser. So address 1, for example, we seem to have 2 options over here. Address 1, we use this address. And for address 2, we use this address. And let me just check which addresses these are. Jumping back into Visual Studio Code, we can check out our front-end folder, DEX, our source folder, tokenlist.json, and I believe it was 0xDAC and 0x514. So we have Chainlink and USDT as the parameters we are searching for over here in this request. Let's go ahead and give this a try, search for these, and we get a response of the empty object, as that is what the endpoint response bit. But now checking out Visual Studio Code, opening up our terminal, look at this, we get the console log of the raw responses of the 2 API requests we made to Moralis. We get the native price in Ethereum of Chainlink, but we also get the USD price, which is 6.7. And then for USDT, we get the native price in Ethereum, but we also get the USD price, which is $1, as USDT is a stable coin. So how sweet is that? We get the token prices super easily and quickly using the Moralis EVM API. So what we can do is use this information that we get the USD price of each token and pass them as the response of our endpoint. So let's close this down. Let's close down our front end files. And I just found myself back in the backend folder in the index.js file. And now rather than console logging response 1 and response 2, let's go ahead and create an object called USD prices. Const USD prices, and for this object we'll have a token 1, which will equal from the raw response of response 1, the USD price, and the same thing for token 2. We'll get the raw response of the response for token 2 and the USD price, and then for the ratio, we'll get the ratio of these two prices. So that will help us calculate in our front end what our tokens will swap into. So over here, we can go ahead and create a ratio of our USD price divided by our USD price of token 2. And now, rather than responding with an empty object, let's go ahead and respond with the USD prices object we create over here. And that is how simple our backend server is actually ready. We can go ahead and test this out. And before this will work, we'll have to go ahead and restart our server once more. So go ahead and run Ctrl+C node index.js. And now we're listening to API calls again. Our backend server is running on port 3001. Jumping back into Google Chrome, we can make this request one more time. Go ahead and press enter, and look at this. The response we get is token 1, the price is $6.7, token 2, the price is $1, and the ratio between the two is 6.7187. How sweet is that? And we can go ahead and change the addresses over here. So for example, if we didn't want to check out Chainlink, we could go ahead and remove this address over here. Go ahead to Visual Studio Code, check out our front end file for the token list in the source folder. Over in here, let's go ahead and, for example, check out wrapped Bitcoin, which should be around $20,000 at the moment. Let's copy this, jump back into Google Chrome and paste it in here. So now we've changed the Bitcoin. So now our token 1, as we make this request, should give about $20,000. Let's go ahead and search. And look at that, exactly as I said, about $20,000, $22,572 to be exact, is the current price of wrapped Bitcoin, and the USDT price is $1, so the ratio is about the same, 22,000. So our backend server is running. Now we have to just hook this up with our front end. Let's go ahead and do that next. So jumping back into Visual Studio Code, we can go ahead and close down our terminals. Let's go ahead and close down all the files we don't need. Let's close down the env file, the index.js file, and back in our front end swap.js component. Let's, in our file structure, also close our backend, and now close our file structure. Jumping back to the top of the file, let's go ahead and make a request to this backend server. And for that, we'll need Axios, which is already a dependency for this project. So let's import it over in here. This is a very simple import. We just import Axios from Axios. And with that, we can also go ahead and create a state variable in which we'll store the prices after we make that request to our backend. So for this, for example, we can create a variable called prices. Using the useState hook, we can set the prices to whatever we get back as a response from our backend. And now let's go ahead and create a function which will actually fetch these prices using Axios and set them to our prices variable. So we have all these functions over here. Let's go down to beneath the last one and go ahead and create a new function. Function fetch prices, and we'll have to pass in two arguments, an argument 1 and an argument 2. So for the two addresses we want to fetch the prices for, we have to pass them every time we call this function. And I actually remember this should be an asynchronous function, as we're going to use Axios and we need to wait for the response. So then we await Axios, but we can actually restore our response, const response, into whatever we get as a response from Axios. So const response is we awaiting from Axios using a GET request to our localhost 3000 token price endpoint, like so, localhost 3001 token price, and then we can pass the query parameters, which are params, like so. Address 1 is what we called it, will be our 1 that we passed to the fetch price function, and the same thing for address 2 will be 2, so the second argument to the fetch prices function. And after we get our response, what we'll do is we'll set our prices variable to the data we get back from our response. For now, we can also console log it, console.log our response.data, so you can see in our browser what the response looks like and what the prices variable is set to. Now, to start off, we can use our use effect hook to to get the initial prices of our tokens. So token list 0 and token list 1. So straight off when you start using the app, you have the prices for USDC and Chainlink. As we go into split screen mode, those are the initial tokens we have set. So let's create that use effect, which we've already imported at this top. If you haven't, make sure you import it from React. Then beneath our fetch prices function, let's create a use effect hook, use effect like so, and it will be triggered on mount of this component. So pass an empty array at the end of your use effect hook. And what it will do, it will just fetch prices with two arguments, token list 0 dot address, and then this token list 1 dot address. So this will get the token prices for USDC and Chainlink for our very initial render of the page, like so. As we jump over in here, let's go into full screen mode. As this is running on mount, as we refresh the page, we should be console logged with the prices of USDC and Chainlink. Let's just test this out. So let's go ahead and refresh the page, then open up our console like so, and React is in test mode. So we get two responses. It runs on mount twice. And look at this, we get an object as a response, and we get a ratio of 1, seems off. So we're getting USDC twice. Let's see what's gone wrong. Of course, we are fetching the price of token list 0 twice. So let's change that to 1. That should change it to Chainlink. Let's save that. And now on mount, it ran again, and we get another object. So the ratio is 0.14, and token 1's price is about $1, and token 2, which is Chainlink, is $6.7. So our fetch price from our backend function is working beautifully. And this is now the format of our prices state variable in our React app. So everything's absolutely awesome. Let's jump back into Visual Studio Code, and we can use now the prices variable to go ahead and change the token 2 amount as we change token 1, as we have the ratio of these two tokens. So let's go find out our change amount function over here. So as we're setting token 1, we're changing token 1, but token 2 remains unchanged. But now as we know the prices, what we can do is go ahead and create a if statement here to check that we have the prices variable and the target value is changed to some number, and then we change the token 2 amount to the ratio of that number. So opening this up full screen for a while, here if we have changed the input 1 and we have prices variable set, we set the token 2 amount to whatever the user changes the target value to, multiplied by the prices ratio. And we also make the UI a bit nicer by fixing it to 2 decimal points. And then otherwise, we just set the token 2 amount to null. So for example, if the user clears the input field, we also clear the input field for token 2. So let's go ahead and save this and see what happens. So opening up this, we go ahead and change USDC to, for example, 6. And that is about 1 Chainlink token. I think 7 might be even closer. So you automatically, because we're making that call to our backend where Moralis is fetching the token prices for this, we get the automatical ratio of these two tokens, and we get how much Chainlink tokens we would get for swapping 7 USDC tokens. That is pretty sweet. But for now, things aren't working, as if we change USDC, for example, to wrapped Ethereum, which is of course way more valuable, this would still give us the same ratio as USDC and Chainlink. So what we have to do is, as we change these tokens, we have to set our input fields to null again, and also we have to make a new request using our fetch prices function to get the new ratio between the two tokens we've just changed to. So let's make these changes first. So as we go ahead and switch tokens over here, let's go ahead and also set everything to null. Over here, setting our prices to null, setting our token 1 amount to null, and setting our token 2 amount to null. And after these are set to null, we swap our tokens around, and then we can make a new request to our backend using our fetch prices function, and this time swapping them around. So now we make the token 1 to be our second token and the token 2 to be our first token as we did the switch. So go ahead and save this and see if that works out. So go ahead and if we refresh the page, now we should have USDC over here. So 7 USDC is equal to about 1 Chainlink token. But as we swap these around, now what we do is 7 Chainlink tokens, that's about 46 USDC tokens. So everything is worked. We made that new request and our backend calculated a new ratio. So now about 1 Chainlink token should be 7 USDC tokens. Check that out. So the ratios of course change because of the prices, but everything is working smoothly with that. The only thing now is if we change the token, that still doesn't change anything. So 1 USDT token should be approximately 1 USDC token. That is not the case right now. So what we have to do is in this modify tokens function, we have to do the same thing. So before we go ahead and change the token, we nullify our prices and the token 1 and token 2 amounts like so. Save that for now. So as we change one of these tokens, for example, to Gemini USD, all these input fields go to null. And then if we go ahead and change token 1, what we'll do is we'll make a new request to our backend using the token we've selected and that address, and the token 2 will remain the same. But if we change token 2, we'll do the same thing, but just swap this around like so. So we use the token 1 original address and the swap token as the second argument for the address, saving that. Now let's go to our app, refresh the page. We have USDC to Chainlink. So 7 is about 1 USDC, but as we change this to, for example, Tether, now 1 USDC, I accidentally pressed 2, but about 2 USDC is approximately 2 USDT. Excellent, excellent. We can swap these around. Everything works nicely. Let's go ahead and try wrap Bitcoin to USDC. 1 wrap Bitcoin is 22,563 USDC. We are absolutely flying. Our backend is working. We're using Moralis Web3 APIs, super easy to use, and we can get instant swap ratios of how our tokens would swap against each other. This is very, very cool. And now before moving on to the last step of connecting our wallet with Wagmi, so we know which wallet is wanting to make the swap and then making that swap using the 1inch Aggregator API, we can make a little sanity check. So if we don't have the prices given from our backend, we shouldn't be able to change this input field 1. So let's go ahead and jump over to the bottom over here where we have input field 1 over here. Of course, input field 2 is disabled. Let's open this full screen. Input field 2 is disabled all the time as we change it based on input 1, but we can disable this as well if we don't have the prices object from our backend. So that is just a nice little sanity check. So if we go ahead and save this, now as you're making your initial launch of the app, this will be disabled for a very short time before we make that request to our backend file and we can actually get the price. Of course, as well, if when you swap these, it's disabled for a very short time. You saw the little X over there because it takes a while to get that price, but now everything should be working. 7 link tokens is 46 USDC tokens. So now let's go on and move on to this connect button over here and let's connect our wallet. I have my wallet over here, which is a MetaMask wallet. We have some test ether over here, so we can make some swaps. We have some USD coins, some Chainlink coins, but let's try and make some swaps after we've done with this and actually try and get some other tokens as well. For example, Uniswap tokens or Tether or whatever we think of is good. But now let's make sure we can try and connect this wallet with this web app so we can then use that wallet to make a transaction. So for that, we'll need Wagmi. Let's open up our development environment full screen, open up our file structure and jump out from the components for a while and jump into index.js over here. And what we'll do over here was we'll use something called Wagmi, which is an awesome Web3 library to make our connection to our decentralized exchange. So go ahead and import a couple of things from Wagmi. We'll configure our chains. We'll use mainnet Ethereum. Of course, there's other chains if you want to use them. Check out Wagmi documentation for that. We'll get the Wagmi configuration and we'll create a client. And then we'll of course need a provider. You could get providers from providers like Alchemy and Infura, but for our cases, it'll suffice to use the public provider. So we destructure that from the providers provided by Wagmi. Now, there's a few initial steps. These will be in the final repo if you want to just copy them from over there, but we're just configuring our chains to use mainnet and the public provider over here. And then we'll create our Web3 client like so using the provider and WebSocket provider. And we'll also set auto connect to true. So when you come to the website, you're automatically connected to your decentralized exchange. If you've already connected and not disconnected your wallet, then all you have to do is wrap your app and our browser router inside the Wagmi config tag with our client we created over here. So go ahead and add Wagmi config with our client, which is equal to client over in here, and close that Wagmi tag over in here, close Wagmi config like so. So now we have Wagmi and Web3 functionality for our React app. That's just something you have to do in the index.js file. I went through this pretty quickly, but this is just some prerequisites. So check this out from the final repo if this was too quick for you. Now, jumping back into our app.js file, which is the root of our app. So here we'll actually provide all the connections and accounts that are connected to our React app and our decentralized exchange. So again, from Wagmi, we can use the hooks, use a connect and use account, and the MetaMask connector to connect to our app. Of course, there are other connectors like the Coinbase wallet connector, Rainbow Kit, etc. I use MetaMask. MetaMask is the most prominent wallet, so we'll use that in this tutorial. If you want to check out some other options, go check them out in the Wagmi documentation. Now, in our app component, which is the root for our whole app, let's go ahead and destructure the address and is connected variables that the use account hook fetches for us, and the connect function that we get from the use connect hook. Like so. So from use account, we can destructure the address that is connected if there is an account connected, and we check if something is connected using the isConnect variable. And then using the useConnect hook and the MetaMask connector, we get a connect function which allows us to connect our wallet to the decentralized exchange or your React app in this case. Now, what we can do is for our header in which we have the connect button, let's actually pass as props all of these different variables and functions like so. So we pass the connect, is connected, and address as their names itself. And we're actually going to pass them to the swap component as well. In the swap component, we don't need to connect as we don't have the connect button. In the swap component, it's only in the header, but we also need to know if we're connected and if we have an address over in the swap component. So let's pass these in there as well. So copy those, paste them over in here. So now all the different components that need Web3 functionality have them, and we can go ahead and jump into the header component. We haven't been in there for a while, but this is very important so we can connect to Web3 through our header component. So jumping back into the header component, what we'll do is we'll get the props. We pass these from our parent component, the app component, and we'll destructure all of them. So we had address, we had is connected, and we had the connect function over from props. So now we have access to these variables and functions over here in our header component as well. And we can actually go ahead and scroll down to the connect button over here. And rather than just presenting the connect in the div, let's go ahead and on click, we'll use the connect function. And then for the contents of this div, let's make it conditional. So whether we are connected, is connected, go ahead and get the address like so, slice the first 4 digits of the address, add 3 periods, and then we'll slice the last 4 characters of the address and paste that. So that'll give a kind of an indication, a nice indication, rather than just having a connect text of which address is connected. But if we are not connected, we'll just have a text saying connect your wallet, please. So that is as simple as it is. That is how simple it is to connect your Web3 wallet to your React app, in this case, our decentralized exchange. And we can go ahead and give it a try straight away. Let's go ahead and save this. So now as we're not connected, we still have the connect text over in here, but let's go ahead and open this in full screen. Let's press connect, and this automatically opens up MetaMask for me. Ask which account we want to connect with. Let's connect with account 1 over here, press next. As you see, MetaMask also uses this form of showing the first few characters, a couple of periods, and then the last 4 characters of your wallet. Let's do that, connect. And now as we're connected, now we have our wallet connected, and it's an indication of which wallet is connected. 0x4d is the wallet that connected, and that is in fact my wallet 0x4d. And we could actually do the same thing if we disconnect this account. We can try and connect and not connect with account 1. Let's connect with account 2, which is 0x5da. Press next, connect. And now it'll show 0x5d is connected to this decentralized exchange. But as account 2 does not have any ether, we can't actually use this. Let's go ahead and disconnect this account, disconnect, and connect back with account 1. Account 1 over here, next, connect. So now we're connected with account 1. everything's beautiful, and we can move on to actually making this transfer with account 1. So jumping back into our development environment, let's open this up in full screen as we'll make quite a few changes. Over here in the swap.js component, we can close all the other ones for now. Scrolling up to the top, we'll have to import a couple of hooks from Wagmi. So what we'll do over here is we'll import useSendTransaction, which will allow us to send a transaction that the 1inch aggregator asks us to send in order to make the swap between two tokens. And then we'll use waitForTransaction later on to make sure to present nicely to the user when the transaction is processing and if it actually goes through. Then as we passed from the app.js some props, we can bring them in over into this component as well, props, and let's destructure them. I believe we had address and is connected, like so. So now we have address and is connected brought in from props, so we can use the address that is connected as the account that will make the swap. And also we can use the is connected variable to check whether we can actually make the swap. So let's go ahead and open these in split screen mode, like so. And as we scroll to the bottom, we already have a disabled swap button if there isn't a token 1 amount, but we can also set an or statement over here if we are not connected is not true. Save that. So now as we disconnect our wallet, let's go ahead and switch to account 1, make sure this is disconnected, disconnect this account. So now we just have the connect. If we go ahead and apply an amount of USDC we want to convert, we still can't make the swap as we're not connected with our wallet. So that is very good. But now moving back into the functionality, let's go ahead and create first a state variable, which will store the transaction details we have to send with the useSendTransaction hook, like so. So we have a transaction details variable that we can set using the useState hook, using the setTransactionDetails function over here. And we have a to address, the data that the 1inch API will return to us as we request a swap, and then the value associated, which will be 0 in most cases, as we don't need to send Ethereum as we're swapping ERC20 tokens with other ERC20 tokens. But back to the 1inch API very shortly. Let's first prepare our useSendTransaction hook. So from the useSendTransaction hook, we'll get data and sendTransaction function. Let's make sure we type const correctly, const like so. And that is coming from useSendTransaction, and it will have some configurations. We'll have a request with an object with a couple of keys. Let's make sure we type request correctly, request like so, and then paste in the keys over in here. So we will send the transaction with these details as the request. The from will be the address that is connected to our decentralized exchange, and the to data and value will be fetched from our transaction details state variable. So as you can see, now if we tried to call the send transaction function, it would not work as we're not passing any correct requests over here, and we're not connected, so we don't even have an address. So we have to create a useEffect hook to make sure that we have these details in order to actually send that transaction. So let's go ahead, and where we have our useEffects at the bottom over here, let's create a new useEffect, where we go ahead and trigger this as transaction details is changed, and we make sure that at the start of this useEffect, we make a if statement and check that we have transaction details. We can, for example, check the to key, and we also have to make sure that we are connected, as this will make sure we have an address. So now, if these conditions are true and the transaction details change, and these transaction details will change when we call the 1inch Aggregator API, we can go ahead and send a transaction from the Wagmi useSendTransaction hook. So it's a bit of a mouthful, but you'll see this working very, very soon. So now we're sending the transaction. Now we just have to make sure that we change these transaction details. And how we change these transaction details is we create another function. So we have our functions over here. Let's add a function, which is an asynchronous function again, async function. And here we'll create that function called fetch DEX swap. And for this, now let's go ahead and open up our browser and check how the 1inch Aggregator API works and which endpoints we can call to make a swap using the 1inch Aggregator. So opening up Google Chrome over here. Here we are in the 1-inch documentation for the aggregation protocol. We're on the Ethereum network and we check all the API endpoints. So first of all, they have the approve method. So when we're making a token swap using an aggregator like 1-inch, the smart contracts that 1-inch has have to be approved to swap your tokens that you have in your wallet. For example, here in my wallet, I have some Ethereum tokens, USDC tokens, and Chainlink tokens, but the 1-inch aggregator won't be allowed to swap these tokens if we haven't approved it first. And over here, we can make a check of using this endpoint, get the number of tokens that 1-inch router is allowed to spend. So we can check a token address. Let's go ahead and get one from Visual Studio Code over here. Let's open up our token list. Let's, for example, get Chainlink tokens over here. Copy this because we have some of these in our wallet. Let's try it out and paste the token address over in here. And our wallet address is over here in MetaMask. Let's copy that, paste that over in here, and go ahead and execute. See what happens. And the request URL that we have to use is over here, so we'll use this later, but the response body is allowance 0. So this means that the 1-inch aggregator smart contracts are not allowed to use any of my Chainlink tokens. But as I've done this already, test this out, it is allowed to do it for my USDC coins. So checking out USDC coins over here, copy that, jump back into our browser and change the token address over here to USDC tokens, execute this. And now as we check, the allowance for USDC tokens is essentially unlimited. So the 1-inch aggregator contract can use USDC tokens in this wallet. So what this means is this is the first check we have to do in our fetch DEX swap function, is to check the allowance of tokens to be swapped in my wallet. And if they are not allowed to swap them, we can use another function, opening up Google Chrome. If we close down this, approved transaction is generating a data for calling the contract in order to allow the 1-inch router to spend our funds. So then we'll have to call this endpoint with the token address, which we want to allow 1-inch to use, and we can leave the amount empty to allow it to use unlimited funds. Of course, if you want to be cautious, you can set an amount of funds that the 1-inch aggregator is allowed to use at once. So let's go ahead and try this for USDC. Let's jump back into this previous call over here where we have the USDC contract, copy that and paste that over here into the approved transaction. Let's try this out. These tokens we want to approve, and let's set unlimited. And this way we get the request URL as well. So now we have this request URL to actually approve 1-inch to make swaps for the token we want to swap out of. So let's go ahead and use these request URLs. Let's use the first one to check whether the 1-inch router has access to our token we want to swap. Let's copy this, jump back into Visual Studio Code, and over here make a variable called allowance, which will await Axios to get. And then here we paste that request URL. Let's just close down our file structure so we can see the whole request URL. And I've already changed this to a template literal. So we're making a call to the 1-inch API, approve allowance, to check the allowance. And we're using the token address, the token 1 we've set from our token list. So it'll be one of these objects, and we're checking the address so we can get the allowance for that token. And the wallet address will be at our address that we are connected to the decentralized exchange with using MetaMask. And this will give us our allowance, and then we can check what the allowance is. So if this allowance, and in the data of the response, checking the allowance key, if this is equal to 0, what we'll do is we'll have to make another call, and that will return us the approval transaction details. So awaiting Axios to get, and then again we have to go to Google Chrome over here for our transaction over here. We use this request URL, and what it will return to us is the data we have to send to the send transaction function of Wagmi, and the to address and the value. So this will be the response body that this request URL will give us. So let's copy that, jump back into Visual Studio Code. I'll already format it to template literals, but you'll have to do that yourself. Like so, make another call to the 1-inch API. this time to the approved transaction endpoint, and we only have to pass the token address, which is our token 1 address that we're wanting to swap. And this will give us the transaction details we have to send using MetaMask. So we can set our transaction details, to whatever the response is from our Axios request to the 1inch API approval endpoint, like so. And now for this, what we can do is we can console log, for example, not approved, and then return this function. But otherwise, if this if statement goes through, and for example, in our case, USDC, which is already approved for us, we can console log make swap, and we'll do that next. But let's give this a go first. Make swap. Let's go ahead and save this and remove our previous console logs. So command find console log response data. Let's remove that. And any other console logs, no other console logs. So now let's go ahead and test this out, save this, open up our browser and our decentralized exchange. So going to Moralis DEX over here, we have to connect our wallet. Let's go make sure first that we refresh the page. This is what we want to swap. Let's go ahead and connect our wallet. Actually, before we can do this, we actually have to call the fetch DEX swap when we click the swap button. So let's go ahead and implement that, jumping into Visual Studio Code, where we have the swap button over here. Let's create a onClick event. OnClick, what we'll do is we'll fetch the DEX swap like so. Save that. Now we're ready to go. Refresh the page. Let's first connect our wallet. Connecting account 1. Next, connect. Everything is beautiful. Now, as we want to make a swap of, say, 1 USDC, let's press the swap, but first inspect at the same time. Let's place the console on the side so it's easier to see. Over here, if we go ahead and press swap, it's allowing us to make the swap as it's not getting stuck in our fetch DEX swap function. Over here, we already have allowance, so it's just going straight over to make the swap. But now if we go ahead and jump into Google Chrome and change these tokens, so we go ahead and try and make a swap of link tokens, which we haven't approved. Let's swap 1 link token. If we try and swap this, it gives us not approved, and we're asked by MetaMask if we're given permission to access your link for the 1inch aggregation smart contract. How sweet is that? It costs a fee of $1.25 for the gas. But we'll reject that for now as we want to test this out later. And we get this error that we denied the request by MetaMask. But now we know everything is working perfectly. And what we can do is go ahead and write that final 1inch API call to get the transaction details to actually make a swap. So jumping back into Visual Studio Code, rather than just console logging make swap, what we'll want to do is we'll want to make another call to make an actual swap. So let's check out the 1inch API. Over here, we have all these open. Let's close these down as we've now figured out how to check our allowance and get the transaction details to access our tokens. Now, as we scroll down, we have the swap method, which has the swap endpoint. And this is what we're going to want to try out. Let's try it out. So we can just try with these basic details, as this will give us the request URL and the sample body. So let's use our wallet. Let's copy our wallet address from over here. Let's paste that over in there. And we actually have to make sure that we have those tokens. Otherwise, the API won't let us make the transaction. So let's check out Visual Studio Code, get some USD coins from over here, get the address of USDC coins, jump back into Google Chrome, paste that address over in here, and make sure that USDC has 6 decimal points. So 1, 2, 3, 4, 5, 6. 1 USDC coin. This should be like so, and we have 1 USDC coin. I think we have about 10 assets. We have 10 USDC coins, so we should be able to make this. Also, you see the slippage, and we actually are storing that, so we can set that in a template literal from our state variables in our React app. And now let's go ahead and execute this, see what it gives us. This is the request URL, and all it gives us is the from token, which is USDC coins. We want to swap, and the 2 coin, which is in this case 1inch tokens. And as we scroll to the bottom, the important information for us is this transaction key, which has all the transaction details we have to set in our React app to make sure that the Wagmi send transaction hook sends the correct transaction to make the swap. So this is what is important for us. Let's copy the request URL, copy that like so, jump back into Visual Studio Code, go to our fetch DEX swap function, and in here, what we will do is create a variable called transaction where we await again from Axios to make a GET request to the 1inch API and paste the request URL over in here. I'll already convert it to a template literal, passing in the arguments we want to swap, like so. So we pasted that in. We're using the swap endpoint from the 1inch API as the from token address. We're using our token 1 address. The to token will be our token 2 address. The amount is relatively trivial because we have to use the decimals of the ERC token. So we take the token 1 amount, which is just in standard units of tokens, but we have to pad it at the end with zeros by the amount of decimals that this token has. So for example, for USDC tokens, we have to pad it with 6 zeros. For other tokens with 18 decimals, we'd have to pad it with 18 zeros. So that's what this section of the URL is doing. And then the from address will of course be the address that we have connected to the decentralized exchange. And then the slippage is our slippage we set in that little slippage popover, which is set to 2.5% at the start, but you can of course change it to 0.5% or 5% using the advanced settings popover. How sweet is that? So now as we have the transactions, we can set the response of these transactions to the transaction details and actually make the transaction of swapping rather than just approving the tokens for swapping. So we paste that over in here, set the transaction details to the data in the transaction response and the transaction key. So if we check that out over again, so as we get the response, we'll have the transaction, which will have the from, the to, the data that we have to send and the value associated with it, and etc. How sweet is that? But one thing we can also do is we actually get the to token amount. So in this key, after we make this request to the 1inch aggregator, it gives the actual amount of tokens that it will be swapped to. So we can display this for the user after they press the swap, so they get the exact amount of tokens that they will get, because there might be changes with different decentralized exchanges that the 1inch aggregator is using. So the Moralis price API is just getting the current price from a set decentralized exchange, but at the 1inch aggregator is aggregating between decentralized exchanges. You might want to display this to the user. So we can do that simply over here. Before we set our transaction details, let's go ahead and get the decimals of our token 2. Over in here, we're getting the decimals and we're turning it into a number like so. And then the token 2 amount we can set to whatever the to token amount key is from our transaction response and dividing that by decimals. So this way we can show in the UI the actual token 2 amount that will be swapped. So let's go ahead and save that. So now everything should be ready to go and we should be able to make our swap. Let's go ahead and try it out. And now, as we already approved for USDC, you've seen that. Let's go ahead and swap these tokens around and let's see how many Chainlink tokens we actually have. Let's see our assets. We have 0.7 Chainlink tokens. So let's try and swap 0.5 of our Chainlink tokens and we should get 3.35 USDC tokens in response for that. But we first need to connect our wallet, of course. Let's go ahead and connect account 1, next, connect. Perfect. So now our swap button is effective. We can go ahead and swap. Let's see what happens first. We're not approved. So we'll have to approve our Chainlink to be used by the 1inch aggregator. Let's confirm this. That is confirming. Let's check out the status of it. It's still pending. And now that was approved. So now we are allowed to use Chainlink tokens. So now we are allowed to use our Chainlink tokens to make swaps for different tokens. So how cool does that sound? Now we can go ahead and press the swap button again, and now we should actually change our Chainlink tokens to USDC tokens. So at this point, I'd like to note that sometimes it might take a while for the information to propagate to the 1inch API, and you might need to disconnect your account and connect it again to make sure that you can make your swap. And another note is that with the current method of sending the token amount we want to swap, using decimals will not work. You'll have to use whole numbers, as over in here, as where we're sending the 1inch swap API call, we're padding the end with zeros. And in this case, we're not moving the decimal point. So only with whole numbers. So if you want to be able to make swaps with decimal point numbers, you'll have to change this method of changing the token amount to the correct representation of decimals to a way where you can actually use decimal. So that's a nice little challenge for you in your own time. But so this means that we'll have to go ahead and change our Chainlink tokens to 1, make sure that we actually have 1 Chainlink token to swap. Yes, we have 1.09 Chainlink tokens to swap. Let's go ahead and swap that. That should give us 6.71 USDC coins. So in the end, we should have about 15 USDC coins. So let's go ahead and make this swap now. And it didn't give us an error that we're not allowed to do it because we are allowed to swap our Chainlink tokens now. We're going to pay a fee of $2.82 in Ethereum for gas. Let's confirm that. And now I noticed one more thing. We could add a little indication that the transaction is processing, as now we'll have to open up MetaMask and actually see the activity. It was just pending, but now it went through. So in our assets now we have 15 USDC and only 0.09 Chainlink tokens. But this means that everything is working. We actually made a swap of tokens. How sweet is that? Let's close down the console over here and create that final functionality of actually seeing the processing status of our swaps. So going back into Visual Studio Code, let's go ahead and jump over to the top of the file over here. And seems like it's automatically brought this send transaction over, but we can remove that and go ahead and we're going to use the use wait per transaction hook to get the status of whether a Web3 transaction is in process and whether it is successful. So go ahead and underneath your use send transaction destructuring, let's destructure from our use wait for transaction, an is loading variable and an is success variable. And as for the hash key that we have to provide, we'll use the data from the use send transaction hook and the hash of that data as long as we have it. So now what we can do is create a use effect for the is loading state and is success state, and depending on those, render a message component from ant_design on the page to indicate to the user that the transaction is processing and whether it's successful or it's not. So let's create that message pop-up first and then hook it up with the is loading and is success states. So we have the message component from ant_design. What we're going to want to do is going to get from the use message hook the message API and a context holder. This context holder will have to pass in to our component. So we have our component all the way down here. We're going to have to pass in the context holder in here, just like so at the top. Context holder, that just makes sure that we can actually present messages in our swap component. Let's save that. And then we are going to go and see where we have our use effects. Here we have our use effects. Let's create one over here, use effect. And what is going to trigger this use effect is the is loading state, is loading. And whether it is loading, we're going to create a new message. So first of all, we'll check if there are any messages on the screen currently. We'll destroy them. And after that, we're going to check like so in a conditional. If the is loading state is true, then we'll create a new message by using the message API open method, and the type will be loading. Again, you can check these in the ant_design documentation. The content will say transaction is pending, and the duration, by setting it to 0, it will run indefinitely until we destroy it, and we'll destroy it here in another use effect, which will be triggered as the is success state variable changes. So is success changes, and making sure that at the start over here, we again destroy any current messages on the screen. And then let me just scroll down and we can paste a conditional that if we have a success state, we open a message API, which is type of success, and say that the transaction is successful, show this for 1.5 seconds, and else if the success state is false, and as long as we have some transaction details, so it's not on the initial mount of the component, we open a error message which says that the transaction failed and display this for 1.5 seconds as well. And that should be it. That should be our whole build ready to go. Let's save this and go test it out. So opening up Google Chrome over here, let's go ahead and check. We have some USD coins. Let's make sure we refresh the page. Let's disconnect our account. Disconnect. Like so, connect it again. Next, connect. Make sure that we're transferring USDC. Let's get a new token. For example, let's swap to some Matic tokens. Let's go ahead and swap. Actually, before we go ahead and swap, let's check that we have Matic tokens in our wallet. Let's go ahead and import some tokens, search for tokens, Matic. Matic network token. Let's add that to our wallet. We have 0 Matic, import the tokens. Scroll back. So our Matic tokens are here. Let's go ahead and swap, say 10 of our USDC tokens. This should give us 10.5 Matic tokens. Let's go ahead and swap those. MetaMask asks us, do we want to make that swap? It'll cost us $3.5 in gas. Let's confirm that. And now we have a transaction is pending state. How sweet is that? We have a message, and that will be pending as long as it's pending here on MetaMask as well. After that's gone through, we should have a success state. Let's check that out. That's successful, and now our transaction should change to transaction successful and be gone in 1.5 seconds. How sweet is that? Now, final check that we actually have the assets. So we don't have 15 USDC anymore, but we have 10 Matic tokens. How sweet is that? That is how you can simply build a decentralized exchange, and that didn't take us too much time at all. I really hope you enjoyed this Moralis Blueprint first episode and you take the learnings from this in your own Web3 development journey, build out your own decentralized exchange, build on top of this project. There's multiple things you can improve on. And again, hope you really enjoyed this video, and I'll catch you in the next one.